use plotting as per your requirement when it is needed. So for plotting, what we need is the data. So we have to first generate data, or we must have data. There are two ways of getting data. One is generating data, that is what I am discussing in this slide. Other is, if data is already available in a file, then you can read from the file. So when we will discuss about files, we will see how to read data from the file and use them. For the time being, for this class, we will see what is data generation. As you know, MATLAB uses arrays of numbers. Now, what does that mean? This means that MATLAB does not understand any function. You can write a function in MATLAB, but that function again uses arrays of numbers. Unlike in C or Fortran, you do not have a specific function facility in MATLAB. MATLAB functions are again using arrays of numbers. So basically in MATLAB, we are related to using arrays of numbers. Now, how to generate arrays of numbers? I am giving you some examples here. A to E, these are some variables which depend on the variable t. A is equal to t to the power 4. So I am writing A is equal to t cat 4 or t hat 4. If t is a single number, it will give you a single number. If t has multiple numbers, multiple values, then this will change as t dot hat 4. Similarly, b is equal to sine 3 pi t. Here you do not require dot star. It is sine 3 star pi star t. So if t is a array, then it will be automatically taken care of, because 3 and pi both are single numbers or scalars. Only if there is a exponentiation or multiplication with another matrix, then you require dot product or dot convention. Otherwise, you don't require dot convention. C is equal to exponential minus 10 star t. Here also same thing as in sine. D is equal to, for a cosine, E is equal to 3 star t. Then it should be a dot hat 5 if t is an array. If t is not an array, then it will be hat 5 only. Minus 4 star t dot hat 3 if it is an array. If t is not an array, it will be only hat t. Plus t. T will be a single number or array. Now, what I am asking you to do, or what we will see in the next slide also, I will do that. Same thing for you. That you generate an array for t. That array contains number between 0 to 20, and they are equispaced by an amount of 0.02. Right? Therefore, in the interval is 0 to 20 with increments of 0.02. So an example program is given below. T is equal to 0 colon 0.02. So second after colon, whatever number comes, unless it is the last colon, then it is always increment. So increment is 0.02, then colon 20. 20 is the last number. 0 is the first number in the array, 20 is the last number in the array of t, and the increments are 0.02. So this makes a vector t in the x direction. Then y is equal to t dot hat 4 to anything. So now you have appropriate y, but only over a specific range. If you have to change the range, you can change always the range above. Now the same thing I have written here in the program format. T is equal to 0 colon 0.02 colon 20. This forms the array t. Then a is equal to t dot hat 4. This generates the power of each element, fourth power of each element in the array. So that is done by dot hat operation. Then b is equal to same 3 pi t, 3 star pi star t of sine. C is equal to exponential minus 10 star t. D is equal to 6 star pi star t. Now in B, C and D, you can see the multipliers of t are all scalar. 3 into pi is a scalar, 10 is a scalar, 6 into pi is scalar. Therefore, we are not using dot star. Then finally, E is equal to 3 star T dot hat. Now dot hat, because T is an array, so dot hat 5. So each element of T will be raised to 5. Similarly, in the second term, it is dot hat 3. Each element will be raised to 3. Last element is T. It will be an array of T. Now, if I run that program, you can see the values of A to E. Now, you can see in that at the end of each row, each line, you can see 3 dots. In each case, 3 dots. Now, these 3 dots indicate that there are more values after these values. After this last value, there are other values are existing. We are not seeing them here. If I put an enter, those value will be shown to us. So this is the generation of data. We have generated data from A to E for given T. T is an array of numbers. So we can now plot A versus T, B versus T, C versus T, D versus T, or E versus T. Now let us see what happens if I go for a line or scatter plot. This is the simplest command, plot. As I have told you, plot is the simplest command for 2D plotting. So by default, if I write plot, then so these brackets, circular brackets, that is the simplest command for 2D plotting. Now suppose in the command window you write type plot y. So that means MATLAB will automatically generate a figure for y, and it will draw the data and connect its lines for y. Now what will be the problem? The problem is, although the plot looks alike as you require, plot looks like a plot, the figure will be drawing a plot, but x-axis units are incorrect because both x and y, both axes will have y. So y versus y, it will be like y versus I, it will be a straight line. If I write type plot x comma y, then in the x-axis it will be x, in the y-axis it will be y values. So this is the ideal plot or identical plot with correct x-axis. If you want more than one plot, then you can write plot x1, y1, s1. S1 is the line type, line number, etc. Similarly, x2, y2, s2. So all that you can write. So this will give you many plots in one command. Plot x is like plot y. It will have a y matrix where x is a matrix. This will plot each column as a separate trace. So if x has more than one column, if it is a matrix, 3 cross 3 matrix, each column will be plotted as a separate trace. Example is shown here. T is equal to 0 to 20, as I have told you earlier. Here it is 0 colon 20, which means increments of 1. So 0, 1, 2, 3, 4, etc. up to 20. Last value is 20. Plot T. Plot T, if I write plot T, as I told you, it will not give me the correct plot. It will give me T versus T, 20 versus 20. So x-axis will be from 0 to 20, y-axis will be from 0 to 20, and each value will be the value of T, that will be a straight line. So that is shown in the top right corner. Then if I write plot T, comma T dot create 2 or T dot hat 2, that means it will plot T versus T square. So that is shown in the second plot here. The second plot shows you, or in the bottom right bottom plot shows you this T square, which is like a parabola. As you know, y is equal to x square is parabola, so it looks like a parabola. Second one looks like a parabola. Third one is for this T, then T square, then T cube, and T4. All those are there, which is in the top bottom left corner. That shows you all the 3 plots are there. In one place, all the 3 plots are there. So you can see, you can draw one plot, you can draw a wrong plot, you can draw a correct plot, and you can draw many plots with same x value or different x values and different y values. So this we had discussed earlier also, so we'll not elaborate on that anymore. Now same thing, we'll see some other features, like if you write plot A, then next command line is plot B, then what will happen? This will plot A, the moment you write plot A and keep enter, or if it is executed plot A command, then the first plot will be done. So you will see a plot which is the first plot. Then once you write plot B, the first plot will be eliminated. There will be no first plot, it will be extinguished, and you will get the second plot. So you will not see both the plots together. So unless you have given a specific instruction to see that both the plots are required, this will eliminate or extinguish the first plot. What is the instruction for seeing both the plots? Instruction is hold on. Hold on instruction gives you command for all plots in one figure. Now on that you can do, you can have many figures. Figure is a command. So if you write figure, then figure, after that if you write plot A, plot B, only you will see plot B, because plot A will come, the plot TA will first come, then plot TA will be extinguished and plot TB will be there. Otherwise you can put plot A on B, so you can have one plot for that. For that you can write plot TA, then hold on, then plot TB. So plot TA will be first, plot A will be there, then plot B will be there. Both will be coexisting simultaneously. If you want two plots, you can write plot TA, so that will give you one figure window. Then you write figure, so one other figure window will be created, and in the second figure window plot TB will create the second plot. This is an example here where we are drawing this t square t versus t square plot. So it is plot t dot hat 2 t is given, t dot hat 2 is given, so you get a parabola, complete parabola you get. Now if I give t dot hat cap, then I will get another plot, but the parabola is missed. So you don't find the parabola here because I have not used the hold on function. Now if I use the hold on function, so on this one shows you the plot t square, then hold on, so and that will be on hold, t square plot will be on hold, that will not be extinguished, and then you will have the t cube plot. So that shows on the right hand side you can see that you have got two plots now. So the parabola is also there and t cube plot is also there. So this is how you can use hold on. Now hold on and hold up, this we have discussed earlier. What is done is, hold on you have to issue once per figure. In one figure you cannot use hold on multiple number of times. So this is something that we left last class. So I am stressing this, that please use hold on once per figure. The result is in all subsequent plot commands, they are going to be one figure only. Figure command or hold up, that eliminates the hold on. It automatically switches off the hold on command. So you will come out of the hold on command if you write figure after the hold on command, or if you write hold up after the hold on command. So this nullifies the hold on. For example, I have given three columns. You can see three columns. Each column shows a set of command. The first command says plot A, hold on, then plot B, plot C, which means plot A will be there, above that plot B and plot C will be there, then hold off, then plot D. Now what will this do? Plot A, B, C were in one plot, now they will be extinguished and only plot D will be there because we have used hold up. Similarly, in the second case, plot A, hold on, plot B, plot C, then hold up, then we are writing figure plot D. In this case, even if we have used hold up, the first figure will not be extinguished. It will remain containing plot A, plot B, plot C. Another figure window will open in which figure plot D will be there. So the next figure window will contain the plot D. Now in the third example, plot A, hold on, plot B, plot C, then figure plot D. Now this is same as the second one. Instead of using fold off, you can straight write figure plot D. So first three plots will be in one figure, second plot will be in another figure. Let us see whether that happens or not in MATLAB. Now you can see that all the three plots are in one figure, t square, t cube and t4. Now let us see the second one. In the second one, now you cannot see t square, t cube, t4, all these three are not there, but t5 is there because we have used hold off. After hold on, t square and t cube plots were given, then hold off. So everything, the first plot is going, only you will get a plot of t5. So that is shown here. Then other figure parts, we need not see the examples. We have already seen examples in the last class. Now in the last class also we saw the pie chart, bar chart, etc. We left out these error bars. Now error bars are something which generate line plus error bars. So at different points, at y plus minus e, or at y lower limit, or at upper limit. So at those points are given, if y lower limit, y upper limit is given, or y plus minus e is given. Using those errors, we will see that error plots. So you can have error bar xye, that is one command. Other command is error bar xy ll lu, lower limit and upper limit, limit lower, limit upper. Now example is given here. T2 is equal to 0 to 10, so increments of 1. If something is, we have defined some f, then we are defining error 1, error 2, 2l and error 2u. So error 1 is 0.1 dot f, or 0.1 star f. So that is the error for first error. Second two, lower and upper bounds are 0.1 star f, and upper bound is 0.25 star f. Now error bar T2 F error 1. So that plots the T2 and F, that plot will be there. With that plot, error 1 also will be there. So that is shown in the top figure. Then we have written figure, so another figure window will come. There we are writing error bar T2 F error 2 L 2 underscore L error 2 underscore U. So you can see that in the second one it is increasing, the error bars are increasing from lower to upper. As you keep on increasing the values, they are also increasing, error bars also, size of error bar are also increasing. In the first case, error bar also is also increasing, but it is small, whereas in the second case it is large, it covers complete error. So this is about everything about 2D plots that we have discussed in the last class, and I tried to cover repeat some of those, or revise some of those, and add few lines to what we discussed in the last class. Now what we did not discuss in the last class is complete range of 3D plot options. We only took one option, which is plot 3. Other ranges we have not taken. So other things are mesh, surf and contour. So there are 3 types of 3D plots, 3 options of 3D plots are there, which are 3 important or main options: mesh, surf and contour. And of course plot 3. Plot 3 we have seen, it is like a line, 3D line plot. But surface plots, if you want to see surface plots, then mesh and surface and contour. So we'll discuss them here today. Now first thing is, you have to have the data set in this case. Give me a minute, let me take some water and we'll discuss this. Now let us see what is data set and why we need data set. Unless you have data, what you are going to plot. So if you have data and data is more than one, it is plural or not one, it is more than one, then you are going to plot that data. Now you know we have 1D case, 2D case and 3D case. Three types of dimensions are available in MATLAB. 1D is it is on a line. So if you want to draw a line, plot only line, a single line, then you require only X data or T data, whatever you say on that, and scattered plots. So on that line you will have scattered points. If you want a 2D plot, what we usually do, 1D plot is a special case of 2D plot, in which case y is equal to 0 for all the time. For 2D plot you have x and y. For each x and y pair you have got a point, right? So for each x and y value, for each x you have got a y value. So you find out x, then you will find out y value. So you move along x to some distance, there find out y value, then you move in the vertical direction to the value of y, there you stop. So that is the point. So similarly you find out all points corresponding to all x given x, then you join those x. That is a 2D plot. And then what will be 3D plot? In the 3D plot, x and y will be given to you. So for each corresponding to each x y pair you have to find out a z, which means in the 2D plot y is a function of x. In the 3D plot z is a function of x and y. So that is the difference in the 3D plot. Now that is the beauty of 3D plot. You have to do that. And also the job at your hand will always be to find out z in terms of x and y, or to find out z as a function of x and y. That is very important, which means you have to find every point, the 2D plot or 2D space on which z is there, every point corresponding to a pair of x and y, divide that into different xy pairs. So for each x find out what will be y. So what are the y values? Then take next x, find out what are the y values. Next x, what are the y values? So you have 10x, which means you will have 10 x values, 10 y values. In total it will be corresponding to each x there are 10 y values. You will have a grid of 100 xy pairs. If you have 10 x values and 10 y values, you will have a grid of 100 xy pairs. If you have 10x, 5y, you will have a grid of 50 xy pairs. So at every for each x and y point, you will have a corresponding, then you will have a corresponding z value. Okay, now go back. Okay. And now suppose I am asking you to draw a plot. Whether it will succeed or fail, that is the homework that you have to do. xyz is equal to peaks 25. Peaks is a function in MATLAB which finds the peak value of a function. So it is given peaks 25, but from that whether you can find out xyz and plot it. Try this and tell me in the next class. Second one is we are trying to create an arbitrary data set. X is from minus 15 to plus 15, y is from minus 15 to plus 15, and z is equal to x dot hat 4 into y dot hat 4. Now you can see that x dot hat 4, then there is a dash, which is it is transpose. Why we are taking transpose? Transpose we are taking, otherwise there will be mismatch in matrix dimension. X is equal to minus 15 to plus 15, which means it is a 1 cross 31 matrix, or it is a row vector. Y is equal to minus 15 to plus 15, it is again a row vector, minus 31, 1 cross 31 row vector. Now the problem is you cannot multiply a row vector with another row vector. You can multiply a column vector with a row vector if it is same amplitude. As you know, matrix multiplication, if you have matrix A and matrix B, then A mn and B should be nk. So row of A should be column of B equal. If they are equal, then only you can multiply. Therefore we are using here this transpose. The moment you make transpose of x, whatever array is there, if you make transpose of x, that will be a 31 cross 1 matrix. right? So that will be easier to find out z. So now you can see what is x, what is y, what is z for each x and each y. Minus 15 to plus 15 dot 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 gives you that, so that there are other values. So x, y, z we have found out for different x, and y we have found out different z values. Now let us see how to plot. The first plot is we have to generate, before plotting we have to generate a mesh grid. So next we will see a mesh grid. What is a mesh grid? Mesh grid is how we are going to generate a mesh. Mesh is like a net. As you know, it is mesh. Mesh means it is grid, vertical grid and horizontal grid. If you put horizontal grids over vertical grids, or vertical grids or vertical lines, you have 10 vertical lines. Above that superimpose 10 horizontal lines. Then they are creating a grid of and there will be many points, 10 and 10 there. So there will be 10 intersection points. So you will have a mesh grid with 10 points, right? So if you have got x, y, a small little x, y, write mesh grid little x, little y, that is called to xy. So capital X comma capital Y within square bracket is equal to mesh grid little x comma little y. So that will give you the points in the mesh, which are the points on which you are going to find out z. So this returns the 2D grid coordinates of each point on the xy plane based on the coordinates contained in vector x and y. X is a matrix where each row is a copy of x, and y is a matrix where each column is a copy of y. Right? And the grid represented by these coordinates x and y has a length y rows and length x columns. Okay, length of y, whatever that length gives you, that is that many rows, and length of x, that many columns. As you know, length command gives you what is the size of the matrix, what is the maximum number of elements or total number of elements in the matrix. Since x and y are 1D matrices, so it will give you the maximum number or length. So what is the total number of elements in the x matrix and y matrix? So those will give you x and y values. So x, y rows and x columns. For example, we are seeing here x is equal to 1 to 3. It will be 1 2 3. Y is equal to 1 to 4. So that will be 1 2 3 4. Now when I write xy is equal to mesh grid of little xy, then capital X will contain the rows 1 2 3 4 times, right? So 1 2 3 1 2 3 1 2 3 1 2 3. So that is 4 times the same rows are repeated. Capital Y is the columns of y, but 3 times. So 1 2 3 4 is first column, second column is 1 2 3 4, third column is 1 2 3 4. Or you can say row, first row is 1 1 1, second row is 2 2 2, third row is 3 3 3, fourth row is 4 4 4. So that creates the xy grid. So the points where you are going to find out z value is at 1 1, then 1 2 1 3 1 4, 2 1 2 2 2 3 2 4. That is how you will find out all the other points on the grid. So you need not worry about that. Just write mesh grid. You will find out in the MATLAB will find out the points for you. So you need not worry about that. Now let us come to the plotting. So the first plotting is mesh. What is a mesh? Mesh is a connecting of points. A series of points are connected, that creates a mesh. Discrete data points with that creates a mesh. So if I write mesh x y z, then what I will get is xi and yj. These are the intersections of the mesh. Capital XY, capital XI and capital YJ. Now please remember, little x and little y are different from capital X and capital Y. Capital X is obtained from little x, and in the capital X we have rows of little x. Capital Y is obtained from little y, and capital Y contains columns of capital Y, little y. So xi and yj, these are intersections of mesh, and zij is the height at those intersection points. So if I is equal to 1, j is equal to 2, then capital X1, capital Y2 will give a point, intersection point, and at that intersection point Z12 will give the value of Z12, and that will be a point. So that point will be connected to Z13, Z23. Those will be gradually connected. So this is the height of that intersection point. Mesh Z, if you write mesh Z, that assumes that capital X and capital Y are simple 1 to n and 1 to m matrices, or 1 to m row and 1 to m column. Now this is an example here. The example shows you xy is equal to mesh grid -8 colon 0.5 colon 8. So that is the mesh grid that is created using xy. R is equal to square root of x dot square, capital X dot square, plus y dot square. Z is equal to sin r upon r. So sin r dot slash r. Mesh xyz. So you can write this way, or you can straightway write z is equal to sin r slash dot sin r dot slash r. Then mesh z. Instead of writing xy, you can straight write z. In both the cases, you will get the same plot, the plot that is shown here. This is a plot with a peak at the center, which is falling off sinusoidally, or as a function of sin c, sinc function. It is falling off sinc function, but it is a 3D sinc function, sort of 3D sinc function. It shows you something like a sinc function, sort of sinc function. Okay, the same thing you can use SORP, but here what happens? The mesh, you will get all the mesh, so it is similar to mesh. So, but these points in the previous figure, the points were joined by lines. Here, after joining by line, the space which is created between different intersections in the line, those space will be filled up. So this is a filled in grid. So SORF is short form for surface. So you get a surface. So that is why it is a filled in grid. Otherwise, it is same as in the previous case. Here instead of mesh, we are writing SURF-Z. So it is SORF-Z. So this gives you a surface plot. Next is contour. Contour means, contour, as you know, contour are always closed curves, closed paths, closed curves. These are contour. A contour contains always a closed curve. Okay. Now, in this case, in the case of 3D plot, sometimes we require to see what will the projection of the 3D plot onto the horizontal plane or XY plane. So, if you want that to have the projection of the 3D plot on the horizontal plane, then you can use this command contour, contour XYZ. For example, we are showing here on the left hand side we have got the SORF plot. On the right hand side it's equivalent contour plot. Now you can compare these two. Now you can see the peak in the SORF plot is yellow. Now you can see, and on the right hand side you can see the center is yellow. Peak is at the center, here at the center it is yellow. So following the same color pattern, the colors are drawn, circles are drawn, and these are going out. These may be circles, may be of any other shape depending on the shape in the SORF plot or mesh plot. You can either use SORF or mesh to generate a plot, and then you can use the contour plot, contour Z. So this is about contour. Now can we have a contour and a mesh simultaneously, or can we have a contour and SORF simultaneously? The answer is yes. You can have a SORF or you can have a mesh, and there you can also have the contour. So the command for that is mesh C or SORF C. So if you write mesh C, you will get a mesh plot, and below the mesh plot on the XY plane you will have the contours. So it's projection of the mesh onto the XY plane. So you will see both mesh and its projection onto the XY plane. So this is mesh C. Similarly, you can use SORF C. We have not showing the SORF C, but you can use the SORF C. Now, how to view the curve? How to view 3D plot? You can rotate it from different angles, different view points. You can see the plot. Now, for that you have to write the command to change the view of the 3D plot is view within bracket az comma el. You can take it x comma y, m comma n, a comma b, anything, but I am writing az comma el. That is to illustrate that az means azimuth. So az is equal to azimuth, which means the rotation around z axis. So if you want to rotate around z axis by an amount, so you can give that value. El is elevation. This is rotation around xy plane. So you can give that value. Useful rotations are 0, 0. You are looking at the 0, 0 x axis, z axis. So rotation around z axis is 0, 0. You do rotate at 0, 0 and 90, 0. So these are the two values for az, el, but you can change it and you can see different plots. And then other important part is the color bar. The color bar is you have a plot and what are the values. It is usually, if you want to know what is the range of values, you use a color bar on the side of the plot, either on the right side or on the left side or below or above it. If you want a vertical color bar, you can write color bar within bracket VERT within quote marks. So that adds a vertical color bar that is shown here in this figure. Similarly, but color bar has to follow the surf command or mesh command or surf C command or mesh C command. So that must precede the color bar command. First you have to write the plot command, then any change in the plot command or any editing in the plot command can be done. Similarly, color bar HORIZ within quote marks, that adds a horizontal color bar. So you can put also a horizontal color bar instead of a vertical color bar. We are showing you one example. By default, color bar is vertical. You can, if you want, you can make it a horizontal color bar. So with this, we will almost complete everything on this 3D plot. Finally, we will go to the C-axis. This sets the range of color in the plot. You may not find it useful right now in the beginning, but as you keep on increasing your practice, you will find it useful. C-axis min max. This will choose the range of colors from the current color map to assign to the plot. So values outside this range will not be used. So it will use only the values which are within the range min max available. Accordingly, it will be plotted. You can see the left hand side is default color, right hand side is we have changed the color min max values. So right hand side is that. So but right now you need not use it. Practice everything else before excluding the C axis. Once you are sufficiently experienced, you can use the C axis. With this, we conclude today's